so how do we find these derivatives? We're going to do it twice just to show that, well, first off, let's show why these functions equal. These functions are equal because if we hearted this, we'd have 1 over sine, which is cosecant, minus cosine over sine, which is cotangent. So these functions are equal, and we're going to take these derivatives in two different ways to show that they will be equal, which obviously they should be, right? Because that's how math works. You can do it in different ways and you'll get the same answer. So first let's do this one because it seems easier, get us a goal to go for. It's because we just take the derivative of both of these and we just know them. The derivative of cosecant should be negative cosecant of x, cotangent of x. The derivative of cotangent of x is negative cosecant squared. So if we're doing minus, those negatives are going to cancel. So it'll be plus cosecant of x squared. And then if we wanted to, just to make it a little better, we could factor cosecant of x out. That might be nicer. And then flip them around. So we're going to have cosecant of x minus cosecant of x minus cotangent of x. So that's the derivative. That's what we're going for. So let's see if we can get that with the quotient rule. So what is the quotient rule? Well, it's the derivative of the top. So the derivative of the top, the derivative of 1 is 0. The derivative of cosine is negative sine. So the negatives cancel. We have positive sine of x. And then minus the derivative of the bottom, which is cosine of x, times the top. And all of that over sine squared. I think this makes sense. So what are we going to do now? Well, let's see. What's going to make most sense to do now? So maybe we heart it now? No, I'm going to go with my first instinct. We're going to distribute that cosine of x. So we're going to distribute the negative cosine of x. So that's negative cosine of x. And then we're going to have plus cosine squared of x. And all of that is going to be over sine squared. Okay. So what are we going to do now? Do I want to separate it into its 3 separate fractions now? That seems decent, I guess. So we have this, sine of x over sine of x squared. So that's going to, one of them's cancel, it'll be 1 over sine, which is cosecant of x, minus cosine of x over sine squared. So that's going to be the, separate that into cosine over sine times 1 over sine. So that's going to be cotangent of x times 1 over sine, so times cosecant of x, and then plus cosine squared over sine squared, so plus cotangent squared. How does that work out? We did everything correct. You know what? We didn't do everything correct, actually. Because this, let's just fix it. We don't need to redo everything. What did we do wrong? So we did the derivative of 1, when we did the derivative of the top, we did the derivative of 1 minus cosine of x, which was positive sine of x. But then that has to be multiplied by the bottom, which is sine of x. We did that properly on the other parts. So what does that change then? That just makes that sine squared, which means when we do sine squared over sine squared, that's going to become a 1. Okay. And that might not seem like it makes a big difference for us, but it actually makes a huge difference. Because now we have 1 plus cotangent squared minus cotangent of x cosecant of x. And what's 1 plus cotangent squared? 1 plus cotangent squared by the Pythagorean identity is cosecant squared. So that's cosecant squared minus cotangent of x times cosecant of x, which is exactly what we got. Because now you see, to get our last step, if we factored out that cosecant of x, we would have cosecant of x minus cotangent of x. So that is beautiful. That is the beauty of math, the beauty of calculus, or yeah, just math in general, that those two functions look totally different and you take their derivatives totally different, but since the functions are equal, that means their derivatives have to be equal. And we can see that they are.